Hi everyone, my name is Suneel Guntur. Today I'm going to discussing about the research paper. The title of the paper is Relevance Aggregation for Neural Networks, Interoperability and Knowledge Discovery on Tabular Data. And the main purpose of this assignment is focus on making neural networks more interoperable when used with tabular data, and it addresses gaps in explainability research which mainly focus on images text. The main goal of this research paper is identity important input features, provide class specific insights, improve other models, example svms, and also use it to detect the detect the hidden biases in the neural network. And when coming to the related research literature, this is research extends current interoperability approaches through the integration of layer-wise relevance progression (LRP) and the deep lift and sensitive analysis. And it highlights the lack of interoperability tools for tabular data in fields like healthcare and the e-commerce. And also it also kind of detects the executing tools are mainly for unstructured data. The study adopts them for the structured data only, and also the absence of the suitable aggregation methods for relevance analysis led to the development of this solution. And the author mentioned multiple research studies that employed LRP for model interpretation. At most of these studies focused on unstructured data sets. And also then coming to the research design or strategy, use LRP to interpret trained neural networks, and also experiments on both synthetic and real data sets. Examples like breast cancer genes, shopping behavior, and also ENEM scores. And also neural networks were trained with ReLU activation, dropout, and ARM adapterizer. Visual tools like the tabular, heat maps, and weights TNB were used for interpretation. These experiments were conducted using Pythons, Keras, and skitlearn and cross validation. And then coming to the results discussion and the conclusion, uh, top ranked features improved performance of external SVMS. The analysis of perturbations demonstrate that removing important features led to the substantial decreases in the module accuracy, thus confirming the significance, and also showed different features mattered for different classes, which identifies the relevant aggregation, improved transparency, and supported knowledge discovery. And finally, it also used to identify the gender-based biases in predictions. And coming to the my contribution, and it introduces a new interpretability. The contribution of this paper is interpretability method for tabular data, supports both global and class level feature analysis, improves external model performance, and helps detect biases, and also useful in real world AI artificial intelligence systems where trust and explanation are needed. And coming to the critical analysis, this paper maintains a clear structure which makes it simple to understand despite its complex technical content, and also provides a solid reasoning, method justification, and result explanation. And this paper also accepted by the reputed journal due to clarity and the contribution. And coming to the research methodology, it has a strong alignment with research questions, used a mixture of real and synthetic data sets, applied robust evaluations techniques like perturbation, accuracy, and checks, used proper training, ReLU, dropout, cross validation, etc. And coming to the research, future research, this paper helped me understand how to interpret techniques like LRP can be adapted for the tabular data, not just images or text, combined with fairness, awareness, logarithms to address the biases. And it is also used to apply to larger healthcare data sets and also finance data sets. It can be used for by the clinical decision supporting system for transparency. And coming to the new knowledge learned, this paper helped me understand how interpretive techniques like LRP can be adapted for tabular data, not just images or text. I learned how relevance segregation and highlighted the important features and exposed model biases. And the visualization methods like weighted STNV were new and interesting to me. What stood out most was how this method supports both understanding and improving models without retaining them. I'm now curious to explore new similar methods in healthcare AI projects, which are used for the future generations and also for the transparency and also for the clinical decision systems. And these are my questions to discuss in future. These are the follow-up questions. How can relevance aggregation be extended to work with assemble or attention-based modules on tablet data? And the second one is how this method can be combined with fairness, awareness techniques to detect and reduce bias in sensitive domains. And this is my reference. I'm going to take this reference as my future purpose. And thank you very much for giving this opportunity. Thank you.